Hi, I'm William Stokes.
Hi, I'm Antonio Vera.
Hi, I'm Joshua Baum, and this is the Foam Flyer 3.0. We are Wednesday 4:30 Team 3.
The goal for this project was to design a model vehicle minimizing weight and drag. The model was required to fulfill these dimension requirements and support a load of 1 kilogram applied at the loading surface. We are also required to produce a CAD drawing of the model.
Due to our team's limited ability with CAD software, we plan to create a simple design using CAD and construct the model using wood.
This is the CAD drawing we created for our preliminary model. And this is the preliminary model itself, the Foam Flyer 1.0. At this stage in the design process, we were primarily concerned with the model's shape, which was intended to roughly replicate that of a real car.
Due to confusion regarding project deadlines, the Foam Flyer 1.0 lacks the sophistication of the final model. It was constructed quickly using tape and cardboard, which were selected for their convenience.
While the preliminary model satisfies the goal of minimal weight, it clearly unable to support the required 1 kilogram load. Additionally, its dimensions slightly exceed the requirements specified previously. We also decided that we could reduce the drag on this model by reducing the cross-sectional area on the final model, as the result predicted by this equation for drag force.
Rather than constructing the final model out of wood as originally planned, we chose to use styrofoam due to its low weight, convenience, and availability. Our second model, the Foam Flyer 2.0, had to be scrapped due to incorrect dimensions. This error could have cost time and money had we chosen wood, but the use of foam allowed us to quickly and inexpensively produce another design iteration with the correct dimensions. We were initially concerned that the foam model would not be able to support the required load, but testing proved that it could.
Our final model features a more streamlined design than the initial prototype, eliminating the flat surface on the front of the vehicle. This flow visualization was the result. What we can see from the flow visualization is that the front of the Foam Flyer is relatively streamlined with not much turbulence. Around the top, the smoke is not flowing as easily and looks like it is pinched before it can get over the top. Flow at the sides are calm, and at the back of the model there are no vortices, which would have created more turbulence.
As a result of our experimental observations and calculations in the lab, we found that the drag on the vehicle is dependent on the vehicle's geometric properties and the Reynolds number of the flow. Increasing the vehicle's cross-sectional area increases drag. Increasing the Reynolds number, which in this case corresponds to the increase in flow velocity, also increases drag.
Since drag negatively impacts mechanical efficiency, minimization of drag is an important goal in many engineering fields. A mechanical engineer designing a car would need to utilize a similar process to the one used in this lab to test a proposed design. He would construct a model and use a wind tunnel to determine the drag coefficient, the Reynolds number, and other dimensionless parameters.